Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2023 VCA, the Northern Hemisphere exam one for maths methods. Yeah, so it just came out, so I'm just going to do it right now and give you the suggested solutions because the solutions come like in another 2 months. So I'll just give these suggested solutions. They are not 100% right. They are my suggested solutions, by the way. So I hope they help. Okay, question 1. A. Find the derivative of y equals sine x with respect to x. Okay, so, I'm not gonna do this quick. I wanna show everyone how to do the questions, and that's what I'm gonna do. So I'm gonna say let u equal x, v equal sine x, u dash equals 1, v dash equal cos x. Now, dy dx, so your actual derivative, so dy dx is equal to u v dash plus v u dash. So that will be here, if I'm going to put it over here, so dy dx is equal to x cos x plus sine x. And that will be it for this one. Next one. Evaluate, okay, so 0 pi over 2, okay, this. So what I'm going to do is, okay, I'm going to say from here, I'm going to write it, so from 0 pi over 2 of x cos it, x plus cos of x dx, which will equal, so I'm going to put a rectangular bracket, so it'll be x squared over 2, so plus sine x, close bracket, from 0 to pi on 2, which will equal square bracket. So if we put pi on 2, so it will be pi squared over 4 divided by 2, which is just multiplied by half, plus, so sine pi over 2, which I'm going to draw over here, so sine, so pi on 2 is 1, so we can say plus 1, I'm just going to minus, so 0, and when sine is 0, it's 0, so yep, we can close that. So that will be pi squared over 8 plus 1. Pi squared over 8, yep, looks right. Question 2. Let f dash of x equal this. Find f of x given that. Okay. So I want to find f of x. It's the integral of 3 minus x to the power of 3 dx. Which is what? It will be square brackets. It will be, so 1 over this, we want to add 1. So 3 plus 1, 4. So we put 4 here. And find the derivative of the inside function, which is just negative 1. We'll put a negative 1 over here. 3 minus x. And make sure you put the new power, which is the 4. Close bracket. And we don't want to forget that plus c. Now expand that, so that'll be negative 1 over 4. 3 minus x to the power of 4. Now, what we can do is we can actually rewrite this. I don't like how it's written. So I can take that negative out. So it'll be x minus 3 power of 4. Is that right? Perfect. And because it's an even power, the negative goes out. So you can rewrite this, the whole thing. You can rewrite the whole thing as x minus 3 to the power of 4 plus c. Now, that's your f of x. We're going to say given that f of 4 equals 5 on 4, we're going to sub that in. So, negative 1 over 4. So, on the x, we're going to put 4. So, 4 minus 3, 1 to the power of 4 plus c equals 5 over 4. That will be negative 1 over 4 plus c equals 5 over 4. And so your c value is 6 over 4, which is equal to 3 over 2. So your final answer, I'm just going to make this shorter, and this is very much small, put it on top of here. So your final answer is here. I'll write it down here. F of x, negative 1 over 4, x minus 3 to the power 4 plus 3 over 2. That's the answer for question 2. I'm just going to highlight the answers for the other ones. So, all right. Perfect. Let's move on. Oh, yuck. Probability. Okay. A school first aid room contains 5 first aid kits. 3 first aid kits are red. 2 are orange. For 3 days in a row, 1 first aid kit is selected at random from an excursion and returned so it's return. Okay, that's good. So we can use it's binomial. Each of the 5 first aid kits has an equal chance of being selected. Okay, let I represent the number of red kits. Red first aid kit selected over 3 days. Okay, so we know n will equal 3 because there's 3 days, and your probability of success of getting red is what? Well, there's a total of 5, and there's 3 red kits, so we'll say 3 on 5. And your Q, which is your orange kits, which is 2 over 5. So what we want to find is the probability of R equals 3, which is what? So it will equal 3, choose 3. So probability of success, 3 on 5. Probability of unsuccess, which is 2 over 5, which will equal, okay, 3 choose 3, what's that? So it will be, that'll be 3 here, 1. Okay, so it'll be 0, 1, 2, 3. It'll be 1, so that will equal 1. 3 to the power 3, that's 27. 5 to the power of 3, which is 1, 2, 5. And the other one becomes 1. So your answer here should be 27 over 1, 2, 5. I hope that's right. Next question. Find the standard deviation of the random variable R. Okay, your standard deviation, is, if I'm not mistaken, it's NP 1 minus P, which is what? So your value of N is 3, your value of P is 3 over 5. Your value of 1 minus P, which is just Q, so it's 2 over 5, is equal to, so 3 times 3 is 9, 18, so it'll be square root of 18, 25, which simplifies to 3 root 2 over 5, if I'm not mistaken. Yep, so 9, 18, 25. Okay, I hope that's the answer. Then we want to here find the probability that I equals 3 and I is greater than 2, given. Okay, so it's conditional probability. So what I'm going to do is I'm going to just rewrite that as probability of R equals 3 intersection R is greater or equal to 2. All over the probability of R is greater or equal to 2. Now I'm going to draw a timeline. And let's say this value over here is 3. And it's a closed dot. And this value over here is 2. It's a closed dot, but goes to the right forever because it's greater than 2. What's the point of intersection? It's just 3. So I will write that as the probability of R equals 3 all over the probability that R is greater or equal to 2. Now, the probability of R equals 3, we just did it before. So it's question A, we did it, which was 27 over 125. Okay, so we can say equals 27. So 27 over 125 all over. Okay, we need to find the probability of R is greater than 2. So to find that, is greater than 2, we can say r is equal to 2 plus r is, oh, sorry, not r like that, but r probability of r is also equal to 3. That's that. So, okay. To do that, I should write over here that this is the probability of r greater or equal to 2. Let me just write that there. So, which is equal to, so probability of r equals to is, okay, it'll be 3, choose 2. So probability of success is, again, 3 over 5, 2 over 5, 1, plus 3, choose 3. So 3 over 5, 3, 2 over 5, 0. So adding all this together, so I'm just going to rub this off. I'm going to put it at the end anyway. And I'm going to just move this over here. I'm going to just rub this, make it nicer. So, okay. We can say the probability of r is greater than or equal to 2 is just over here. Okay. Which is, okay, which is equal to, so 3 choose 1, if I go on top, okay, 3 choose 1. So 3 choose 2, sorry. So it's 0, 1, 2, so it's a 3. We say 3. So 3 squared is 9 over 25 multiplied by 2 over 5. Plus, so 3 choose 3 is 1. So plus 1, 27, 125, and the other one becomes 1, which is therefore equal to 9 times, okay, so 9 times 9, 18, 27, so it's, we're saying it's 27, 25, times 2 over 5, plus 27 over 125. So it's 27 times 2, which would be 54 over 125 plus 27 over 125, which is equal to 71 over 125. Is that right? Oh, 81. Oh my God, why do I write 71 here? 81. So, that's for that. I'm just going to make this a little smaller. Make this small. Oops. I'm going to make this small. I'm going to put it over here. Now, this now equals. So we know the probability if r equals 3, which was 27 over 125 all over r is greater than 2, which is 81 over 125, which is therefore equal, so 27 over 125 divided by that is 27 over 81. Yep, is that that? Yep. So, therefore, I'm just going to write this as final answer. Therefore, your final answer, so your probability, when r equals 3 given r is greater than or equal to 2 is equal to 27 over 81. Okay, I hope that's right. Okay, I'm just going to highlight that. Okay, let's move on to the next question. So, next question is, let g of x equal this. Evaluate g log 2, okay, giving you answer as an integer. Okay, so, g, I want to just change color for this one. So, g log 2, 3 is equal to 2 to the power, so 2 log 2, 3 minus 9 times 2 log 2, 3 plus, so we want to plus 20 equals what? So we can do, we can put the 2 inside, so it'll be 9 minus 9 times, because these have the same base. What does that mean? It just becomes 3. So negative 9 times 3 plus 20, which here it's the same, so it will be 9 minus 9, that'll be 3 here, plus 20, which is equal to 29 minus 9, 18, 27, so 27, therefore it's equal to 2 as your answer. That's that. Solve g of x equal to 0. Okay, I see a pattern here. I see like it looks similar to a question that's in the textbook. So if we want g of x to equal 0, so we'll say 2x minus 9 times 2x plus 20 equal 0. We want to let a variable like u equal 2 to the power of x. So here it would be u squared minus 9 times u plus 20 equals 0. Factorizing this, so 5 and 4 will be u minus 5, u minus 4 equal 0. Therefore, u is equal to 5 and u is equal to 4. Now, again, we know that u is equal to 2x, so we're going to write u, we're going to sub back 2x in there to u, so it'll be 2x on 5 and 2x equals 4. Now, I'm just going to continue this, so we're saying 2x plus, 2x equals 5, and we're going to say log 2 of 5 equals x. Now, for this one, x is just equal to 2. So 2 to the power of 2 is equal to 4. So we can just say x is also equal to 2. So those are your two solutions. Okay. All right, question. Let me just do different color. Let's do green. Consider question 5. Consider a continuous random variable x with a probability density function f given by this, where c and d are all reals and c is greater or equal to 1. Find d in terms of c. Okay, so what I'm going to do is I'm going to find the integral. I'm going to find the integral from negative d to d of the function. So I can actually take the half out anyway, of x plus c dx equals 1. Because if we go to the lower bound and the upper one and we find the full area, it should be equal to 1 because its probability, the max value is 1. So let's simplify that. So it'll be half, put round brackets, so it'll be x squared over 2 plus cx, close brackets, so d here, negative d here, and that's all equal to 1. So I'm still going to leave the half outside, and I'm going to sub in the first d. So it'll be d squared over 2 plus cd minus, it'll be d squared over 2 minus dc here. Okay, and close bracket equals 1. So we can say a half of that is equal to d squared over 2 plus cd minus d squared over 2 plus dc is equal to 1. So these cancel out, by the way. These two cancel out, which leaves us with half cd plus cd, which is 2cd, is equal to 1, which is therefore, if we come up here, it's cd is actually equal to 1. So we want to find D in terms of C. So therefore D is 1 over C. That is your answer for that. Perfect. Hope that's right. 3 marks. Okay. Is that right? C is greater than 1. So okay, let's just double check something. So C is greater than 1. So let's say unequal to 1. So if I put 1, D, it can be 0. Okay. Yep, it looks right. Makes sense. Okay. All right. Let's move on next. Okay. Given that the expected value of x is 1 over 24, find the values of C and D. Okay. So I know that the integral of from negative D to D and multiplying by x of the function f of x, which in terms was x plus c over 2, x plus c over 2, dx is equal to 1 over 24, which is your expected value. So doing this, I can take the half out still, so I'm going to take the half, and I'm just going to expand everything out. So it will be x squared plus cx dx equals 1 over 24. So 1/2, okay, and then we put, so it'll be x3 over 3 plus cx squared over 2, close brackets, and it's all equal to 1 over 24. Yep, so I'm going to put that half, I'm going to multiply by all, so it'll be x. Actually, let me just get rid of that half. How? If I multiply both sides by 2, so if I multiply this side by 2, I have to multiply this side by 2, so it would just be x to the power 3 over 3 plus cx squared over 2 equals 1 over 12. Okay. What is the common denominator? It's 12. So this will be 4x to the power 3. This one here would be, so if I put a 12 here, it'll be 6 cx squared equals 1. And what can we determine? Okay, have we done anything wrong here? Okay, now, what is this? Have I done something wrong here? Wait, so expected value negative d to d. If I took that x, okay, and I can multiply half, x squared plus cx dx equals half, okay. And I've took x to the 3 over 3 plus cx squared over 2, put half, okay. Took rid of the half by 2. Okay, so 12. Okay, so looks right. Now, what am I going to do? So, to calculate the value of C, what am I going to do? Okay, look, I'm very confused why. Let me just rub this off for a fact. And I won't multiply them by 2. I won't multiply both sides by 2. Let me just keep it. And let's see what happens. So, x3 over 6 plus cx squared over 4 equals 1 over 24. Okay. Oh my god, I was so confused. I'm just like, what's happening? Okay, what am I doing? I forgot those values. Negative d to d. That's why I'm just confused. I'm like, okay. Careful. Let's do this slowly. Okay, now I need to sub in those values. So it'll be half. So the first value, which is d to the power 3 over 3 plus cd squared over 2 minus, it'll be minus d to the power of 3 over 3, and here will be plus cd squared over 2. Okay, now I know this. Oh my god, yeah, I was just so confused. Okay, now, half, okay, so it'll be d3 plus CD squared over 2 plus D3 over 3 minus CD squared over 2. Okay, so CD squared, these cancel out, and your answer here will be just D to the power of 3. Yep, so when we add these together, okay, equals 1 over 24. Now, if I multiply 3 on the other side, it'll be 1 over 8. So A, or D, 1 over 2. So it'll be, D is half. So if I know D is half, and I come back here and I know that D is equal to 1 over C, it means that your value of C is 1 over, so wait, your value is, so of C is 1 over D, which is just 2. If I'm not mistaken, yeah. Yep. Perfect. So these are your answers. All right. These are your answers. That was not hard. It's just I got mixed up. Wow. A lot of too much working out. Okay. Let's look at question 6. Consider the function f where f is, okay, we don't know the domain. F of x is this. So it's a rectangular hyperbola where d is the maximal domain. Set the maximal domain. Okay. So to state the maximal domain, I know for a fact that the denominator, so x minus 1, must not equal 0. So therefore x must not equal 0. Must not equal 1. So we can rewrite this as x is an element of all reals with the exception of 1. That's your domain for this one. Sketch the graph of f of x, label any asymptote with the equation and the axial intercepts. Okay, so I know that there's going to be x equals 1 and asymptote x equals 1. So I'm just going to draw this. I'm just going to draw x equals, okay, x equals 1 and at x equals 3. So, all right, and I know that the graph will look like this because it has a positive dilation, so it's not reflected. That's good to know. So what I'm going to do is I'm going to calculate the value of the y-intercept and the x-intercept. So for the y-intercept, I'm going to let f equal 0, so that will be 3 minus 2, which is 1. So is that true? So 3 minus, okay, so yeah. I'm going to use this color. So it's going to be over here. What about your x? What about your x intercept? We're going to let f of x equal 0 and we solve for. So we're going to say negative 3, 2 over x minus 1, negative 2 over 3, x minus 1. So negative 2 on 3, we can say 3 minus 2 over 3, which is 1/3. Okay, so 1/3. That's good. 1/3. Okay. So 1/3 should be, I don't know, around here. I'm just going to now label them. So this one over here is 1/3 over 0. This point over here is 0 to 1. And I forgot to label my asymptotes. So this one will be y equals 3, x equals 1. So we've labeled the asymptotes with the equation and the axial intercepts. And now let's just sketch it. So this is how the graph's going to look. All right. So it's going to pretty much look like this. So it should be approaching down here. And it should go like this. Okay, wait, that's 2. We're just going to go like this. And it should have that same distance. So from here to here, it should have around the same distance, somewhere around here. And we can say, this goes over here, and this goes over here. And we can just work that out, this mark out. Okay. That's good. So, have we labeled everything? Yep, your axis, nothing else, yeah? Yeah, that's it. Looks like that's right. Nothing looks wrong. Okay. Now let's look at C. Let G, okay, we're all reals with the exception of 0. Okay, G of x is this. Okay, determine the rule of the function h such that the graph of y equals h g x minus y is identical to the graph of f of x. So, we know f of x. Okay, what is f of x? F of x 3 plus 2. So, 3 plus 2, I think x minus 1, was it? X minus 1? Yep, so it should, yep, x minus 1. So what we want to do is we want to pretty much, okay, it says g x minus 1. So if we say g x minus 1, that'll give us 1 over x minus 1. So what we're saying is, what's a function of h of x? So h of x is like a function, blah, blah, blah. And if we shove in, like if we shove in this over here into it, into the x value, we should receive this. So, okay, let's just try to do something that could give us h of x. Let's say h of x equals let's say plus 2, plus 3 actually. So h of x equals plus 3. So h of x equals 3. So h of x, something like that. So h of x equals 3. No, it doesn't look good. So h of x is, because there's a 2, I think I'm just going to say 2x. So let's try that out. So h 1x minus 1, that'll be 2x minus 1. Okay, and we just need to have something that puts a 3 there. So if we put a 3 on the h of x, like the function, what happens? So it will be, again, 2x minus 1 plus 3. Okay. Yeah, that's your h of x, actually. That's not too hard. Yeah, it's just trial and error here, but okay, that's your h of x. Wait, determine the rule of a function h of x. Is that it? Okay, is identical to the graph of it. Yeah, so this is your function h of x. That's h of x. Is there anything else we need to do? F of x, that. And that's just because it's 2 marks, I'm just going to say h. And if we put 1x minus 1, it's equal to 3 plus 2x minus 1. That should, yeah, give that mark. Let's look at question 7. Let f of x equal log blah, blah, blah. Find the implied domain. Okay, for a log function, to find the domain, we look at the inside function and we solve for x when it's greater than 0, for example. So the inside function is 3 plus 2x minus x squared. We want it to be greater than 0. Now, what I'm going to do here is I can just rewrite this. Negative x squared plus 2x plus 3 is greater than 0. I can take a negative out, so it'll be x squared minus 2x minus 3 greater than 0. Now, if I divide both sides by negative, like negative 1, to get rid of that negative 1, it will become x squared minus 2x minus 3. The inequality sign actually changes, so it becomes opposite, less than 0. So if I'm going to factor this out, so it'll be 3, 1. So 1 minus 3 is negative 2. Perfect. So this will be x plus 1 equals, yep, it's less than 0. That's what we want to find out. So if I'm going to just draw a nice sketch over here. Yep, so let's say this is negative 1 and this is 3 and it is nice and positive. All right, something like that. So that's negative 1, this is 3. And we want to find out where it's less than 0. So over here, this is where it's less than 0. So it's less than 0 for x is an element. Oh, actually, let's just write it like this. Much better. Let's write it as x is between, just not equal, so x is between 3 and negative 1. That's your answer. You can write it as this. There we go. State the x-coordinate for the local maximum. Local maximum. How do I do that? Okay, so normally to find the local maximum, so we normally would do f dash of x. So let's do f dash of x, which is what? Okay, we know that if we have a log e f of x, and we want to find the derivative, so the f of x is a function, and we want to find the derivative of this function, we say dy dx is f dash of x. So the inner function is, we find the derivative of it and we divide it by the actual inner function itself. So that's what we're going to do for this one. So the inner function is 3 plus 2x, so the derivative of it is just 2 minus 2x all over 3 plus 2x minus x squared. Okay, let me rub that out. Now, we want to let f dash of x equals 0 here. So, if we let that equal 0, so 2 minus 2x, 3 plus 2x minus x squared is equal to 0, we can say that 2 minus 2x equals 0, so x equals 1. This is just state the x-coordinate. Okay, I'm not too sure for this one, so what I'm going to do is just, I'm going to start estimating. For example, I'll take this x equals 1. I'm just going to rub this out, and I'm just going to draw a graph of the function. I'm going to start, okay, so this is how it looks. So this is your x, and this is your y. I know that the domain is between -1 to 3. So let's say here is -1, and here is 1, 2, 3. Say 3 is over here. And we know that they're not included because probably there's an asymptote. So I'm just going to draw some red lines, like asymptote lines here at this part here. And, okay, so we only have these values here. We have 1 and 2. So let's sub in 1 to the function. So if we sub in 1 to the function, so we're saying 3 plus, so 2, so we're saying 3 plus 2 minus 1. So we're just saying 3 plus 1, which is 4. So log e 4, which is, let's say it's over here. So log e 4 is here. What about 2? So if we put 2, so it'll be 3 plus 4 minus 4, so it's 3, so it becomes less, so it's over here. And what about 0? So we have 0 over here. So if we put 0, it's 3, log e3, which is the same here. Okay. And, okay, so the graph looks like this. So it looks like it's going down like a parabola. Okay, so that's your maximum point. So your maximum point, yeah, it's x equals 1. X equals 1. Over here, yeah, so x equals 1, which I wasn't sure because I just took this out, like I just multiplied by 0, so yeah, okay, hope that's right. So find the values of x, okay. Next question, find the values of x, so values of x for which f of x is equal to 0. So we want log e, so log e 3 plus 2x, so 3 plus 2x minus x squared to equal 0. Is that okay? For that, we say e to the power 0 is 3 plus 2x minus x squared. 1 minus 3 plus 2x minus x squared. If we bring that x squared to the front, so minus 2x minus 3 plus 1 equals 0. So x squared minus 2x minus 2 equals 0. I know for a fact this, I'm just going to use the quadratic formula. So we're going to say negative b, so it'll be 2 plus 1 negative b squared, which is just 4 minus 4 negative 2 over 2. So your x value is 2 plus, what's 4? 8, so plus 8 over 2, so x is equal to 2 plus or negative. So a plus is, we can say 2 for a 12, so 3 over 2. So x values is equal to 1 plus or negative root 3. Yeah, is that right? Okay. Yeah, those are the values of x. We're just gonna make this a little smaller. I'm just gonna make this smaller over here. And here's your answers. So here's your values of x. Hope that's right. So just gonna highlight that. Highlight this one too. Okay, move on to the next question. Is this the last question? Okay, that's the last question. Perfect. So, okay. So the last question is always the hardest one. So let's just take our time with this. Consider the function f, where f is all reals, and we have f of x. Okay, and we have this function. And a function g, where the domain of g is all reals, but the equation of g is not known. Okay, so let me just, so this graph over here, right over here, not the best, okay, so this graph over here is your f of x. And this graph over here, I'm going to put on red, is your g of x. Okay, and we don't know g of x. So, let's look at the equation. Parts of a graph of f of x and g of x are shown below. Both functions pass through the origin. Okay, so over here. So, based on the graph above, state one reason why the graph of y equals g of x, so, okay, is not the graph of y equals f dash of x. So, they're saying that f dash of x is not equal to g dash of x. That's what they're saying. Is that right? Okay, so f dash of x. Okay, and it makes fully true, because if you literally look at the turning points, look, now we know that when, let's say f is the normal, okay, so let's say f is right now like the actual function, and every turning point, for example, there's a turning point over here. Now, normally when we draw the f dash of x, it always touches, then it always becomes at x. So it always has to touch the x-axis when there's a turning point. So, example, there's a turning point over here. It should be touching over here too. It also has a turning point here, so it should be touching here, over here, here, here. So it has a lot of turning points. So we can see that it's not g of x, because if you look at g of x just touches the graph at 1, 2, and that's it. It touches it at 2 points. So we can say, so based on the above, state one reason why the graph of g is not, okay, the graph, we can say, the graph of f dash of x, so f of x has many we're going to say the graph of f of x has many turning points. If g of x was f dash of x, then g of x would have many x values. I don't know if that would give you the mark, but yeah, it should. Okay, let's go to the next question. Determine the equation of g of x given that g dash of x is equal to f of x. Okay, so now, okay, so g of dash of x, so we want to find g of x. Okay, so g dash of x, so g dash of x is equal to f of x. Okay, f of x is this, so 1 over 3x squared, so just x squared over 3 plus sine pi x. Okay, pi x. Okay, so what we're going to do is, to get g of x, I mean, we have to integrate both sides. So if we integrate both sides, it will be g of x integral from, just integral of x squared over 3 plus sine pi x dx. Okay, which is what? So if we put a round bracket, so it'll be, think of it, pull that 1/3 out, so it'll be multiplied by x3 over 3 plus 1 over pi, so normally sine, so it will be negative cos pi x. Okay. Plus c, which here would be x3 9 plus, not plus, so we want to say negative, minus 1 over pi cos pi x plus c. So that's your g of x. Now we can find the value of c because we know that g of x, so when g is, when the x value is 0, the y value is 0 because that's the origin. They told us that they are equal. So we can say 0 is equal to, that'll be 0, negative 1 pi. So cos 0 is 1. So just 1 plus c. So your value of c is 1 over pi. So I'm just going to make this smaller now. This is too much. I'm going to make this smaller. I'm going to put it over here. So your final answer, so your g of x is equal to x 3 over 9 minus 1 over pi cos pi x plus 1 over pi. That is your answer. That should be your answer for this one. Okay, looks right. Hope it is. Okay, let's just move on to the next question. Is this the last page? Okay, this is the last page. The last page always has the hardest question, so let's take our time. So some functions have the property f of x equals f minus x for all, okay? Show that when two functions m and n have this property, the function k of x also has the property. Okay, so can we say any, so some functions have the property, show that when two okay, so we can make up functions. I know that this property is, for example, if I'm going to draw, okay, I'm going to draw something like this. Okay, so normally what they're saying is, let's say x is equal, let's say x is negative 1, so negative 1 here. And when it's negative 1, it's a positive value, so here. And when we put x equals negative, so if the same value should be the same y value. So even if it's a negative 1, if it becomes 1, so it becomes a positive value, it should always have the same y value. That's what it's saying. So things that have this term to be parabolas, so we can say one of the functions that we can make up is, let's say mx equals, let's say x squared, the basic parabola. What else does have this? So n of x. I know something else. I remember there was a function. Wait. So f of x. Okay. Say. Okay. Was it sin x? No, it was cos x. It was cos x. So let's say f of x was cos x. So it means that f minus x is cos minus x. But anything that's negative numbers in cos tend to get away. They tend to be just positive. So cos x. So they are the same. So also we can say cos x can also be that function. Okay, so overall we can say, so show that when two functions m and n have the properties of these, the function k of x also has the property. Okay, so now k of x is now the addition of these two, so k squared plus cos x. So we want to show that when kx, we want to show it equals k minus x. So first, what's kx? It's just x squared plus cos x. And what's k minus x? It's x squared plus cos x. I don't know, hence k kx equals k minus x. Is that right for a mark? So mx we've named 2 and we've just said k. Yeah, I think that's all right. Okay, let's move on to D, which is your last question. Okay, this is, consider the function h, where h of x is this. Okay, so we have a c value that we don't know. Find all the values, okay, all the values of c for which h of x equals h minus x for all. Okay. Okay, so what I'm going to do for this one is, okay, so h of x is, so I'm going to equate them. So h of x equals h minus x. So that'll be 1 over 3 x squared plus sine pi x minus c equals 1 over 3 x squared plus sine. So if we put negative x, it'll be negative pi x minus c. Okay. Have I done anything wrong here? Just double checking. Nope. Okay. Now, these 1 through over x squared just are useless, by the way, because they don't even have a c value and they can just be cancelled out. So overall, this is what we have. So sine pi x minus c equals sine negative pi x minus c. Okay, what can I do here? Well, by using the property here, we know that when we take, so sine pi x minus c, if we say sine, and we take a negative factor out, so it'll be pi x plus c. Yep, and if we take that negative, it'll just become negative sine. So by properties, by symmetrical properties, so it'll be negative sine pi x plus c. If you guys did not understand what it was, so what I did was we know that sine theta, or like sine, let's say sine negative theta. So we have a negative theta inside. It's equal to negative sine theta. That's what I just did over here. That's the property that I did. All right, what can I do here? Okay, to solve for values of c, I think what I'm going to do is I'm going to just sketch a graph, a very big graph actually. Let me just draw a big graph. I just want to draw a big graph. Okay. Because these to find, so, okay. So let's draw the first one. So let's use color red for the first one, which is this one over here. First, let's let c equal 0. Let's just say c is equal to 0, and let's just find a period. So 2 pi over pi is just equal to 2. So this one is a positive, so it's just going to go 1, 2. I'm just going to do 2 rotations, like that. And this value here is 0. This is 1. This is 2, 3, and 4. That's for that graph over here. When c equals 0. That's when c equals 0. What about for this one? I'm just going to use a purple graph for this one. So it still has the same period, but it's the negative sign. So it's going to be like this. Something like this. Something like that. Okay. And what we're going to do is, how are we going to make, let's say c equals, let's just put a value of c because it's for 3 marks. Okay, let's guess some values. Okay, so if we say, to make them equal, let's say c equals, so I'm just going to do this first. So I'm going to write the first one, so sine, I'm going to take that pi out, so it'll be pi minus c over pi. Okay, so if we move the red graph to the right, so we would say normally c pi, let's say we moved it to the right by 1. So let's move that red pi 1 unit. Okay, it'll be like this. Okay. That's good. But the problem is, if we let C equal, so we let C equal actually, so when we, so when we let, so we take that pi here, so x minus C pi. So when we said that x minus C pi is equal to, when we rotated it to the right, we said x minus 1. So this will be negative C pi, negative 1. So C pi is 1. So C equals pi. So we moved it, so our C value is pi. But yeah, so what we did is we, just trying to think here. Okay, so if we moved it 1 unit, am I doing something? Wait, this C equals, so we take the x here. What am I doing here? Okay, that's not considered. Okay, so look, if we moved, say, 1 unit to the right, so if we moved it 1 unit to the right, that the red graph, what will happen is that we will actually move this one to the left by 1 unit. So the purple graph will move to the left by 1 unit, which will be over here. And they're not equal now. They're actually not intersecting anywhere. So here, they're not actually equal. What can we do? What other values can we use? What about if we say we rotate it halfways, for example? Let's put it all together. So put this back here. And let's put this over here. What about if we move the red graph by half? So if we move this by half, then this one also must move half. Okay, now they're intersecting. So now they're equaling. So what is the value? So actually, what's the value for that? So we just said that, okay, if we take that pi out of there first, so pi x minus C pi. Okay, and that x minus C pi is because we moved the red graph to the, we moved to the right by half. So we would say, we moved it by half. It would be, so negative C pi, so negative C pi equals half. So it would be pi over 2, negative pi over 2. Your C value here was negative pi over 2. So C value was negative pi over 2 when we moved it. Okay. And it should be the same. So even C equals pi over 2. So even the positive value, so negative pi over 2, they actually equal the same. They should do the same thing. For example, let's put this all back together. Now let's do the same. So pi over 2, so let's say put this backwards by half a unit. So let's here. And this one over here will go forwards. Okay, they're still intersecting. We can see that they're still intersecting. So, okay, so the pi over 2 and negative pi over 2. So okay, I'm looking for a pattern here. So I think I've got a pattern here. So if I put these all back together and say now through pi over 2, so 2 times pi over 2, so integer values of pi over 2, what would happen? So this one over here will go, let's say we'll go right 2 times. This one will go right 2 times. Wait, what have I done here? Oh, sorry. Let me put that back. Okay, so we said that this one will go over here if it was through pi over 2, and this one would go this way over here. Okay, it's still intersecting. We can still, they're still intersecting. So I think the pattern here is they are integer values of pi over 2. Pi over 2. Okay, so the integer values, they're going by pi over 2. So we can say that x, or C, our values of C, is just pi over 2n, where n is an element of all integers. So n equals 1. It will do the same. Negative 1, same thing. So yeah, I mean, that's that. Is that the answer? I hope it is. Not too sure, but yeah, I think that's the answer. All right, I hope you guys enjoyed. please make sure to like and subscribe. And guys, I do tutoring, private tutoring. If you want private tutoring, my email is linked down below, and you can just email me there, and yeah, we can have a discussion. So this exam was all right. I'm not going to say it was bad. It was actually an all right exam. Maybe the last question was, I don't know how students would finish that at the end. It's because, like, how? I don't know. You have to give a lot of time for that. And how many marks? It was 3 marks. Yeah, 3 marks. Okay, guys. Hope you guys enjoyed this video, and please make sure to like and subscribe and share with your friends. Have a good day.